Alrighty, this is for section 3.2, logarithmic functions. Your essential question is, what is a logarithm and how are they used? So, the logarithmic function is the inverse function of the exponential function. So what you see here on the screen is they start with f of x is equal to b to the x power, which is exponential. And then they go through all the steps we learned to find inverse functions. So first, you change f of x here to y, and then you switch x and y, and then you solve for y. And then what do you get? Well, we don't know how to solve for y in this instance, and this is how the logarithm came about. Okay, so what we like to say, and right here is the important part, right? So y is equal to the log base b of x is equivalent to b to the y power is equal to x. Okay, so if you notice here in logarithmic form, and you might want to write this down, y represents the exponent in exponential form, and the base of the exponential form is always put as a subscript under the log. Just as here we have our base that corresponds, so this moves to here, this y becomes our exponent, and of course the x after log becomes what we're trying to solve. So what they've shown you here is a way to think about it is if you start with something like this, you just move the b out in front of the y and make that the exponent, and then y becomes x. So it's very simple. So what we want to do here now is we want to write each of these equations in their equivalent exponential form. So for part A, I have 2 is equal to log base 5 of x. So A, 2 is equal to, okay, so when I convert this, 5 is my base, 2 is my exponent, and that is equal to x. Okay, for part B, okay, we have 3 is equal to log base b, 64. This becomes b to the third power is equal to 64. Okay, why don't you pause the video, try part C, and then we can pick it up. Okay, part C. So C says log base 3 of 7 is equal to y. This becomes 3 to the y is equal to 7. Alright, so that's how you convert from logarithmic form to exponential form. For this checkpoint, go ahead and have an attempt at all 3 of them, and then pause it, and then compare it with what you have. Alright, so here you can compare what you got with each of your solutions. Remember, the base of the log becomes the base of the exponential form, and then whatever it's equal to, that becomes the exponent. Alright, so for example 2 now, we're going to take things in exponential form and turn them into logarithmic form. So here now, if we look at part A, so if I have 12 squared equal to x, okay, remember that here the base raised to the y power is equal to x. This is going to become log base b of x is equal to y. So if we use that, okay, so our base is 12, so this is going to be log base 12, okay, of x is going to be equal to 2. Okay, so if you compare what you have in this right here, that should match up with what we have here. So for part B, b cubed equal to 8 is going to become log base b of 8 is equal to 3. And finally for C, e to the y, remember that's the number e that we learned about last lesson, is equal to 9. That becomes log base e of 9 is equal to y. Now, what I want to add here, and we're going to learn this definitely a little later in this lesson, is log base e is actually, it's very special. So we can actually rewrite log base e. So this becomes the ln of 9 is equal to y. But again, we're gonna learn this a little bit later. All right, so take a second, try these, and then compare them with the results. Okay, go ahead and pause the video. So here are the results for letters A, B, and C. If you'd like, go ahead and you can pause the video and compare with how you did. Okay, so if we want to evaluate logarithms, sometimes it's easier to try to think of it a little differently. So for this first one, log 2 of 16, we need to kind of think of a question that we're thinking of. So the way to tackle this is I always start with the base. So 2 to what power is equal to 16? So that's quite easy. So if we now take a look at it, 2 to the 4th power is equal to 16. So log 2 of 16 has to be equal to 4. Okay. A little bit differently, log 7 of 1 over 49 basically says, okay, 7 to what power is equal to 1/49th? Well, we know 7 squared is equal to 49, so this tells us that 7 to the negative 2nd power is equal to 1 over 49. Okay, and because remember, when that exponent's negative, what that does is it tells you it's going to go down into the denominator. So here now, log of base 7 of 1 over 49 is equal to negative 2. Okay. So, again, like the other ones in part C, log 25, so I say 25 to what power is equal to 5? Well, I know the square root of 25 is 5, so 25 to the 1/2, or log of 25 of 5 is equal to 1/2. Okay. Take a second and try to do these 4 problems, and then compare your results. So here are the results. On this last one I was a little messy, so forgive this, that's not there, it's actually 7. This might be the hardest one here. So keep in mind, when I set this up, this needs to, remember, is actually to the 1/7th power, and that's what gives you your solution. Okay, so we're going to look at some basic logarithmic properties, and let's pay attention to this first one right here. So what it says is, it says log base b of b is equal to 1. Because, remember, this is my exponent, so anything to the first power is just going to result in itself. So that's very simple. And similarly, log base b of 1 is equal to 0, because, remember, anything to the 0 power is 1. While you don't see these all the time, they are kind of helpful to see in certain situations. Okay, so what I'd like you to do is very quickly evaluate log 7 of 7. So log base 7 of 7 is equal to x. So 7 to the x power is equal to 7. Oh look, x must be equal to 1. And then for the second one, log 5 of 1 is equal to question mark. So 5 to the question mark is equal to 1. Well, anything to the 0 power, so the question mark must be 0. So that's very quick and simple. Okay. These two are actually a lot more important than the other two. So if we have log base b of b to the x power, then that has to be equal to x. And similarly, if we have b and our exponent is a log base b of x, then that answer is just x. So if we're just going to look at these two, and particularly the first one for part A, so I'm going to rewrite it. Log base b of b to the x is equal to x. So log of 4 to the 5th, that has to be equal to 5 using the property there. Again, with the second property, b raised to log base b of x is equal to x. So if we have 6 log 6 of 9, that also has to be equal to 9. But like I said, these two properties you'll see a lot more other than the first two properties. Alright, so this is your assignment for the entire section. All I want you to do for tonight, do on Wednesday, is the underlined in red part, please. So page 410, 3 through 31 odd, and 21 through 31 odd.